Good morning everyone, I am Subhashini Mudaliar. Today I am going to start a new topic, that is equilibrium. Now what is equilibrium? Equilibrium is a condition where the reactant and product both are not doing proper reaction. At that stage it's a equilibrium. So let's go and study clearly about equilibrium. Equilibrium represents the state of a process in which the properties like temperature, pressure, concentration of a system do not show any change with the passage of time. That's what we have told right now, that reactant reacts to form a product, and then after some time, due to some conditions, the product again come back to the in a form of a reactant. So, if the opposing processes involve only physical changes, the equilibrium is called physical equilibrium. If the opposing process involve chemical changes, that is, the opposing process are chemical reactions, the equilibrium is called a chemical equilibrium. So, there are two different types of equilibrium in a chemical process. There is a reversible process as well as irreversible reactions. Now, you know very well what is a reversible reactions. A reaction in which not only the reactant reacts to form a product under certain conditions, but also product react to form reactants under the same condition is called reversible reactions. In other words, a reaction which takes place not only in the forward direction but also in the backward direction under the same condition is called reversible reactions. Forward reaction shows what? A plus B is a forward reaction. C plus D when is a product. So when C plus D again reverts back to A plus B, that is a backward reaction. So this is a reversible reaction. What was that? A plus B is a reactant, react to form a C plus D. This is the rate of forward reaction. C plus D is a product. When it comes back to the position A plus B, it's a reversible reaction. Got it? Now the second one is a irreversible reaction. If a reaction which cannot be take place in the reverse direction, that is the product formed do not react to give back the reactant under the same condition, it is called irreversible reaction. That is, A plus B gives C plus D. Now what was C plus D? C plus D is a product form. Now it is not going to react back to the A plus B. So this is a irreversible reaction. Means product formed which is constant. It is not going to back to the reactant. So this is a irreversible reaction. So here the graph represents some concepts of chemical equilibrium. So the graph indicates the x and the y axis, that is G. G is for the Gibbs energy, and the progress, that is R into N coordinate, shows what? X and y axis, that is a reactant and product. As you can see here, this is a reactant and this is a product. So reactant tries to go to the product, and once the product formed, it again tries to back to its position to the reactant. So the number 2 shows what? The reversible reaction. So it shows the concept of the chemical equilibrium. So here it is the state of a minimum Gibbs energy. Gibbs energy is what? Energy required to the reactant to form a product, right? That is a Gibbs energy. In the previous chapter in the thermodynamics, we have studied about the Gibbs free energy, enthalpy, entropy, internal energy. Do you remember that, right? So here dg, that is equals to 0, delta G equals to 0 at this stage. So here the rate of forward reaction, that is equal to the rate of backward reactions, which is very, very important. Here rate of forward reaction, that is equal to rate of backward reactions. So this equilibrium is a dynamic and stable in the nature. Now, what is the dynamic nature of a chemical equilibrium? In the Haber process, what is Haber process? A scientist named Fritz Haber has invented some reaction or for preparation of ammonia with the suitable environmental product, that is nitrogen and hydrogen. So when nitrogen and hydrogen reacts to form one product, that is the ammonia, and again it is a reversible, it comes back to the nitrogen and in the form of nitrogen and the hydrogen. In the Haber process, starting with the definite amount of nitrogen and hydrogen and carrying out the reaction at a particular temperature. So when equilibrium is attained, the concentration of nitrogen, hydrogen and ammonia become constant. So there are some certain conditions at some time where the nitrogen, hydrogen and ammonia, for example, I would like to write here the equation, that is nitrogen N2 plus hydrogen H2, reversible condition, gives 2NH3 ammonia. How to? Because N2 is there, so N2 is there. Hydrogen is 3H2, means 6, and here 3 to 6. So at certain time, what happened? The number of moles of nitrogen and hydrogen reacted to form ammonia. But after the preparation of ammonia, it again comes back to the form of nitrogen and hydrogen. So there are some molecules of ammonia and there are some molecules of hydrogen and some molecules of nitrogen. So this condition is what? A dynamic, this is a chemical equilibrium. What is that? It's a chemical equilibrium. So if the experiment is repeated by taking the deuterium in place of hydrogen but with some same amount, exactly similar conditions as before, equilibrium is attained containing D2 and ND3 in a place of H2 and NH3, but in the same amount. Now if the two reactions mixtures are mixed, then after some time it is found that the concentration of ammonia and hydrogen are same, except that now all forms of ammonia, that is NH3, what are the different forms it forms over here? NH3, NH2D, NHD2 and ND3. These are all the forms of the ammonia, and some or all forms of hydrogen is H2, HD and D2 are present over here. So this shows that equilibrium, the reaction is still going on, that is equilibrium is in a dynamic in a nature. So these are the conditions for the chemical equilibrium. So here the graph shows the reactant as well as the product. So hydrogen, nitrogen are the reactant. So hydrogen and nitrogen, when comes in contact with each other and reacts with each other, it forms a product. As it is reversible, it comes back to the position of atoms of nitrogen and the hydrogen. So here shows what molar concentration versus the time. So as the time increases, obviously the product formation is there, but at certain condition, a certain time, the product formed is still constant there, and again it comes back to its reactant form. There are some characteristics of the chemical equilibrium. At equilibrium, the concentration of each of the reactant and the product become constant. Second point is what? At equilibrium, the rate of the forward reaction becomes equal to the rate of backward reactions. This we have studied right now. That rate of forward reactions that becomes equal to the rate of backward reaction, and hence the equilibrium is dynamic in nature. Chemical equilibrium can be established only if none of the product is allowed to escape out or separate out as a solid. For example, if carbon dioxide gas escapes out in the case of decomposition of CaCO3, calcium carbonate, the reaction will no longer remain reversible. Similarly, the reaction is irreversible if one of the products separate out as a solid. So, for example, look at here, AgNO3 plus KCl gives AgCl and KNO3. Here it will come KNO3. So the arrow mark down shows what? Precipitation, which shows what? Precipitation means a solid particles, right? So the next point is what? There are some other characteristics, that is chemical equilibrium can attain from either direction, that is from the direction of the reactant as well as from the direction of the product. So understood, this is the chemical equilibrium which can be attained from either direction, that is from the direction of the reactant as well as from the direction of the product. So equilibrium means what? It shows that the reaction comes from reactant to product or from product to reactant. This is called a chemical equilibrium. Now the next topic is rate of reaction. Now what is the rate of reaction? Means how many work done by the reactant. That is the rate of reactions. So average rate, that is equals to change in concentration upon time taken. Now change in concentration means what? Final concentration minus initial concentration. Change in concentration means what? When the work done, when the reaction occurred. So before the work, what was the concentration, and after the work done, what was the concentration. That is delta C equals to final concentration minus initial concentration, right? So average rate, that is equals to change in concentration upon time taken, that is delta C by delta T. Now instantaneous reactions. Now what is instantaneous reaction? That is it comes under a derivative, that is a differentiation, that is delta C by delta T, that is equals to dC by dt. At the limitation is what? Delta T tends to 0, means T2 minus T1 is 0. So that is dC by dt. Unit of rate is what? Unit of rate of a reaction is what? Concentration upon time, or we can say mole per liter. Now this is till what we are doing. In the next PPT we will show you the rate of forward reaction, rate of backward reactions, and equilibrium constant, and many more. Thank you. Hope you understood the topic very well. Read the chapter, try to solve it. Thank you.